Okay, so for example 1, what we're going to do is we're going to actually write the equation for this particular hyperbola. Okay, now we're going to look at the different working parts, but the first thing we have to do is find which one is your transverse axis. We've got to determine if the transverse axis is vertical, okay, or horizontal. Okay, so transverse axis is always where you're going to start. Okay, so the transverse axis, okay, is it vertical or horizontal? Okay, now in this particular one, we've got a vertical transverse axis. Okay, so let's go ahead and circle vertical, and we've got to think about which one we're going to use there. Well, let's look at our equations. Okay, when the transverse axis is vertical, y is going to go first. So this is the one we're going to use for this particular example. Okay, so let's go ahead and write that. Okay, so we've got y minus k. Okay, that quantity squared over a squared minus x minus h squared all over b squared. Now, there's 4 parts that we need to fill out. Okay, we need to fill out a, we need to fill out k, h, and then b. Okay, now, don't forget that a is always going to be your length, right, from the center to the foci along, so, center is somewhere over here. We'll get the exact value in a sec, but the center along that transverse axis, okay, which we determined was here, and it's that distance from the center to the foci. Okay, sorry, the center to the vertices, or to the vertex. Okay, so let's go ahead and find our center first. Okay, well, looks like we've got a, it's a peak here, so -6. Okay, and then we've got to find kind of that distance, right? So we're looking at 9 and then -3. Okay, so we're going to kind of split that in half. That's going to be 6. Okay, so we've got 3, 3, that's going to be my halfway point. Okay, so that's going to be my h comma k. Let's just go ahead and write that down. Actually, let's go ahead and replace it. Okay, so I've got a -6. Okay, that's my h coordinate. Okay, so -6 right here. Okay, but when I write that -6, I've got to change this to a positive, so it's going to end up being x plus 6. Okay, now for the y coordinate, right, for my k, nothing changes. Again, h comma k is always going to be your center, so this is your k value right here. We've got +3, so that's what we're going to put in here. Okay, so y minus 3. Now, so we got that taken care of. Okay, now we just got to find, we've got to find a, we've got to find b, and then we've got to find our, well, we're going to use c to find one of these two. So there's that working relationship between A, B, and C, and the reason you don't even actually need to always find C, but in this particular one, I'm going to go ahead and tell you that you do need to find C. Okay, so let's look at A. Well, A is always along that transverse axis, so here's your center. Back to the center, we got -6, 3, and we're literally just going to count our way to either the top or the bottom. Doesn't matter. Okay, so let's go ahead and do the top. Okay, so we got 1, 2, 3, 4, 5, 6. Okay, so that is going to be your A. Okay, so that's going to be your A. All right, so we've got that taken care of. Okay, now for B. Okay, the question is, how do we find B? Okay, well, you've got to use that C value. Okay, now the relationship between C and A and B, don't forget, okay, that in this, for a hyperbola, okay, this was in that textbook, that, the little section that I showed you, okay, for a hyperbola, the relationship between A, B, and C is as follows. So C is actually equal to the square root of A squared, okay, and then plus B squared, always. Okay, that's always going to be the case for a hyperbola. All right, so we got equals. Okay, well, we know A. Okay, so we've got, this is 6 squared, so I'll go ahead and fill that one in. Problem is we don't actually know B. Okay, now the reason we don't know B is because, look, -6, 3, well, where does it end? All right, we don't know. There's no information that actually helps us find B. So we've actually got to use C in this particular one. Okay, now C, don't forget, is the distance between the center to one of the foci. Okay, so it's again the distance from the center to one of the foci. All right, so that's where this kind of comes into play. We actually know our C this time before we know our B. Okay, so let's go ahead and do it. We got -6 comma 3. Well, let's count. Well, we know this is 6. Okay, and we know this length is 4. So my C is actually 10. Okay, so I'm actually going to go ahead and erase that. We've got 10 is equal to the square root of a squared plus b squared. So again, 10 here. Okay, and then plus b squared. Okay, so we've got 10 equals, well, we can, actually, let's go ahead and get rid of the square root. Okay, right, square root, so we'll square both sides. I got 100 is equal to 6 squared. Well, what is 6 squared? That's 36. So 36, and then plus b squared. So over here, we'll get, subtract 36 on both sides, so we get 64 is equal to b squared, which lets b be 8. Okay, so we now have our b right in there, and we can fill it into our equation. Okay, and then that's going to give us all the information we need. Okay, so that would be the equation for this particular hyperbola. Okay, so it's a little bit weird with A, B, and C there. Okay, you've got to actually use that C to help you find B in this particular example. Okay, so you got to really understand what C is. C is that distance between the center, okay, to one of the foci. Okay, so either one doesn't actually matter. All right, just looking back on a few important things. The main thing, guys, is once you find that center, okay, you've got to remember that your A value is always going to be to the vertex, okay, and it's going to be along that transverse axis. That's super important, okay? So your A value is always going to connect the vertices, okay? Just, moving forward, that's a super important aspect about hyperbolas, okay? All right, we'll have one more example. I'll do that in the next video.